Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. We are continuing with our study of solving systems of linear equations, and in this video we'll be looking at solving by matrix techniques or matrix inverse techniques. So we have a system of linear equations that we've seen before that we can write in matrix form as AX equals B. What we want to do this time is take advantage of the definition of the matrix inverse. So if you multiplied both sides of this AX equals B by A inverse, so here and here, then what you see is that A inverse times A is the same as the identity matrix. And the identity matrix times any other matrix just gives back that matrix, assuming all the sizes work out. But in a system of equations, if you have n equations and unknowns, this always works. And so therefore x is going to equal A inverse times B. Now this works as long as you have an inverse that is non-zero. This relates back to Cramer's rule saying that the determinant can't be zero. So as long as I can take the inverse of matrix A that's non-zero, then the product of that times B will give me my answer X. I can do this in Excel using, again, matrix techniques. So I'm going to use the matrix inverse, and I'm going to be using matrix multiply. But let's talk about how this works. So to do this, what I have to do first is highlight a block of cells. So you can see down here, I highlighted a block of cells that is where I want to put the answer. And you start by typing in equals minverse, an open parenthesis, and then highlight the cell of the matrix that you want to take the inverse of. Close the parenthesis, and then this is the part that makes this work. Instead of just hitting enter and moving on, you have to hit Control-Shift-Enter. If ever you want to have the answer be a matrix, you have to use Control-Shift-Enter. And you can also do this in VBA and create a macro, which is shown here. You can also multiply two matrices. Very similar. You're going to start by highlighting where you want your answers to go. So right here, I highlighted it. And you type A equals M mult, so matrix multiply, open your parenthesis, highlight the first matrix, so maybe here, type a comma, and then highlight your second matrix. So I don't have anything shown here, but maybe it's right here. Close your parenthesis. I want the answer to be in a matrix form, so use Control-Shift-Enter. You can combine these, so I've shown this here, that I can do the matrix product of the inverse of matrix A and the column matrix here. And so this is combining the two steps. If we do this for this problem that we were looking at in the previous lesson, I've got that shown here. So this is my A and my B. And what I would say is that my X matrix is equal to, and so I start by highlighting, and I'm going to, it's the product of the inverse of A, comma, with this column here. And then I close with closing all my parentheses, Control-Shift-Enter, and I end up with these answers. And you see that these answers match the answers that I got before. So this is, again, another way of doing this. You can do this in one step, or you could have done this in multiple steps if you preferred. Just simply, if I wanted to do the inverse only, equals matrix inverse of A, Control Shift Enter, and that's the inverse. I can do matrix multiply. Order matters, so it's this one multiplied by this one. Control Shift Enter. So that's doing it in 2 steps. Just as a confirmation, if I wanted to multiply and show that the product of the matrix and its inverse give me the identity matrix, it shouldn't matter on this one which order I do. They're both square matrices. So if I multiply A and its inverse, Control Shift Enter, what I see is I get 1s across the diagonal, and I get 0s, or essentially 0s, off diagonal. Now notice that those are not strictly speaking 0, but they are so close to 0 that this is just a matter of round off error. So this concludes this lesson. In our next lesson, we're going to look at ways that we can use row manipulations to come up with answers to a system of equations. Thank you very much for your time.